Hello and welcome to another coding challenge. This challenge, I'm going to attempt something called pixel sorting. And pixel sorting is an algorithm that takes all the pixels of an image or a video or anything and reorganizes them in some order, maybe ordered by brightness or ordered by hue. Maybe they spiral out from the center, or they kind of get ordered across or up and down. And you can see if you Google an image search with pixel sorting, you'll see a lot of artists and people making art and crazy projects with a pixel sorting algorithm. So I am now going to try to make pixel sorting in Processing, which is a Java-based programming environment. It looks something like this. You can go to processing.org to download it yourself. And the one thing that I've got going here is in this, the code is in a PDE file called pixelsorting.pde. Check this video's description for a link to the code. I also have an image, a JPEG, in the data folder. So you can use any image. I've just grabbed off of Wikipedia an image of a sunflower, and that's what I'm going to pixel sort. So first thing I want to do is I want to create a p-image variable, and then I'm going to say image load image, and it's sunflower.jpg, and then I want to draw the image, image 0, 0. So I want to see here, the canvas that you're going to see is 800 by 400. So what I want to do now is have the raw image on the left and the sorted image on the right. Okay, so I've got part one. Now, here's the thing. What I want now is another image called sorted. And I want to create a blank image equals create image. And I want it to be the same width and height. And I want it to be an RGB image as the image. So this in processing is how I load an image from the file. Here's how I create a blank image. So now, and let's just do something really quickly. Now, all images, oh, look at this. There's a weird bar here. I don't know. That's a glitch with my camera. I'm just going to have to live with it. But all images, the pixels, we think of them as organized on a grid. Like here's pixel like 0, 1, 2, comma 0, 1. That's pixel 2, comma 1. The computer stores all the pixels in a linear list. 0, 1, 2, 3, 4, 5, 6, 7. So to the computer, this is actually pixel index 7, which is actually the 8th pixel because I started counting from 0. So, and in processing, I can look at all of the pixels of an image, that array, by saying the image dot pixels itself. So I'm going to come over here. I also need to do something like, say, sorted.load pixels. This is kind of like a little announcement, like, hey, I'm going to look at the pixels now. And I'm going to say I'm going to write a for loop. I equals 0. I is less than sorted.pixels.length. I plus plus. And I'm going to say sorted dot pixels index I equals a color random 255. So processing has a function called color, and if you give it a single number, it'll make a nice grayscale color, and it'll put in that pixel, in that image. And then I can say sorted.update pixels. I'm not doing the sorting yet. I'm just showing you how this works. So now, if in the draw function, I say I draw the image and I draw both the original image and this quote unquote sorted image, which is now just random colors, I should see this. So we can see I have an image that's loaded from a file and an image with pixels that I made up. So now what I need to do is take all of these pixels and put them in this one to sort it. So actually, something that I could do right here is I could say image.pixels index I, and I could say image.load pixels. So now this is me manually, one at a time, copying every pixel from image into sorted. Here we go. Ta-da, 2 sunflowers. By the way, I love sunflowers. Do you love sunflowers? Tell me about your favorite flower in the comments. And then you can write, oh, cringe, cringe. This seems to be the thing that people write whenever I talk about flowers or kittens or puppies or rainbows or whatever. But you know, these things are nice things. Can we have nice things, please? Okay, so now I need time. By the way, I'm avoiding. I'm like stressed out here and procrastinating. I got to get to the sorting. So here's the thing. Most programming environments will come with some kind of function to sort an array. And Java is no exception. Even processing is no exception. It has a sort function. But the thing is, I need to do something kind of custom here because this array is like this crazy array of colors. And I want to like organize it. They're arbitrary numbers. A color is an R, a G, and a B value, and an alpha value sometimes. So how I'm going to sort it, I've got to write the sorting algorithm manually. Sorting algorithms are the domain of people's PhD dissertations and lifetimes of study. There's something called a bubble sort. There's something called a selection sort. There's even something called a quick sort. And I probably, for what I'm going to do, could make great use out of a super fancy, efficient, fast sorting algorithm. There's a great write-up, I believe, by Mike Bostock, who's the creator of D3, about sorting algorithms and how they work. I'll link to that in this video's description. But for what I'm going to do right here, just to make things simple, I'm going to implement a selection sort. And so I think the way that I can do this, right, I have two arrays. Ooh, you can't see all of that. I'm cut off, but that's fine. This is my first array. I'm going to look through the entire array for the brightest pixel. When I find the brightest pixel, I am going to put that over here. And what I'm actually going to do is I'm going to have to, you know what I need to do? I actually need to copy the whole image because I need to rearrange the pixels while I'm sorting, but I don't want to mess with the original pixels of the image. So I'm going to copy the whole image. And let's talk about the selection sort again. I realize I need to do this in a different way than I had previously imagined. I'm going to look at all the pixels of the image, find the brightest one. Let's say this is the brightest one. I'm going to take this and put it in the first spot, and take that first spot and put it there. That's called a swap. Then I can start from here and now look for the brightest one, and take that one and put it in the second spot. Then I can start from here and look for the brightest one. So I'm kind of looping through the entire array to find the brightest one to put it in the first part. Then I'm starting at the second, the third, the fourth. So I'm always getting a smaller section of the array because the beginning, and that will grow, is the sort of sorted part. So let's see if I can do that. And one thing I can do so this is a way that I copied all of the pixels. Just in case you're wondering, I could actually, I believe, say sorted equals image.get. So that's a get is a function in processing that just gets a copy of the image. Let's see if that works. Great, so that's a little easier than copying the pixels manually, just so you see that's there. And now what I need to do is I need a selection sort. So let's think about how I'm going to do this again. I'm going to say for, and I do need sorted.load pixels. I'm going to say for int I equals 0, I is less than sorted.pixels.length, I++. Okay? So this is looking at every single pixel. But for every single pixel, I need to look at all the pixels that come after it. So I need to say for int j equals starting at I. J is less than sorted.pixels.length, j++. Okay, right? Because I want to start, again, if I come back to that diagram, I want to start at 0 and look through all the pixels. Then I want to go to 1 and look through all the pixels. Then I want to go to 2 and look through all the pixels. Okay? So that's what this nested loop is doing. So the first thing I need to do is let me sort by brightness. So I'm going to say B equals the brightness. Let's get a color, pix, equals sorted index j, sorted.pixels index j. That is the color at that particular pixel. The brightness of that color, I could compute it, but processing has these nice functions that'll it's just the average of the RGB values. So I'm going to get that brightness. Now what do I need? I need to find the record brightness of any pixel for each time I do this. So I'm going to create a variable called record, and I'm going to set it to -1, right? Because no pixel can have a brightness less than -1, less than 0. So I want to say, and then I want to, I'm going to say brightest index. You know what I'm going to do? Because I might change the algorithm. I'm going to say selected pixel equals I. Because I can start, by default, I'm going to start with the first one. Selected pixel equals I. So what I want to do now and say, if brightness is greater than the record, then that's the selected pixel is now J, and the record is now that brightness. So this is like looking at every pixel from J to the end and seeing if its brightness beats whatever previous brightest one I found, storing it as a selected and storing a record. So now once I finish this loop, now what I do is swap selected pixel with I. So I need to take whatever was selected as the brightest and put it in the I spot, and then whatever's in the I spot, stick it back somewhere else. So how do I do this? Basically what I want to say is sorted.pixels index selected pixel equals sorted.pixels index I. And then sorted.pixels index I equals sorted.pixels index selected. So this won't work, by the way. This is a problem. So, but this is like a nice idea, right? I want to take what's in I and put it in selected pixel, and what's in selected pixel and put it in I. Here's the problem, though, and I prefer to write it. I don't know. This is like kind of nonsense, but I need to feel like okay about things in life generally. For some reason, I need I to be first. That's just how I am. I want to take what's in selected pixel and put it in I, and then what's in I and put it in selected pixel. The problem is I just overwrote what was in I, so I've lost it. So what I actually need is something like a temporary variable to store what's in sorted pixels index I, and so that I can put that in temp. That didn't make any sense. Let me say that again. I need to save what's in I because I'm about to overwrite what's in I so that I can grab it again and put it in selected pixel. This is an algorithm for swapping two spots in the array. And then once I'm done, I think this is everything. This should actually work. Now, I have no idea how long this is going to take. This is not a particularly efficient algorithm, and there's this thing called like big O notation that people talk about in like computer science of like how fast is an algorithm. This is like an n squared algorithm because for every pixel I need to check every pixel. So if there were just 10 pixels, I have basically got like 100 checks. But if there's 100 pixels, I've got 1, 0, 0, 0, 0, 10,000 checks. So I hope I did that math right. So this is kind of with a 400 by 400 image, there's going to be a lot of pixels to check. So let's run this and see what happens. Okay, I'm back. That took a really long time because it takes a really long time. There's 400 times 400 pixels. There's a lot of pixels to sort. This I'm going to have to, I sampled the image down to a 200 by 200 image, which I think it can sort it in Java in about 14 seconds. So I'm going to run that now. And you can see the window's a little bit smaller, but I'll zoom into it. 1,000, 2, 1,000. Come on, pixel sort. Come on, do the pixel sort. Cringe. That's what you do while you're watching. And you complain and type in the comments. Oh, there you go. So you can see this now sorted every pixel horizontally by brightness. Let's see if we can sort it by hue, which I think will be interesting to try. Okay, so instead of looking at the brightness, why don't I look at the hue? So processing has a function called hue, which will give me the hue value of a particular color. So I can actually look at that. And I believe this should take just about the same amount of time. Do the pixel sort by hue. Do the pixel sort by hue. This could get edited out maybe someday too, and it could just appear. So you can see, look at that. This edited nicely by hue. And so you can see I have all of these sort of like orangey colors at the bottom, yellow colors. We're getting this nice sort of palette. So this is pixel sorting. Now, the thing is, I'm just doing sort of like the raw basic algorithm. You should take this code, find the link and get up and be creative with it. So first of all, you should think about what's another way you could imagine sorting the pixels besides just brightness or hue. Here's another thing. I'm just ordering them horizontally. What if I order them vertically? Or what if I order them spiraling out from the center or coming in from the edges? What types of other strange, what if I only sort part of the image? And you'll see lots of art. If you Google image search pixel sorting art, you'll find a lot of creative examples of this, and I hope you make something and send it to me. But before I go, I want to add one more thing to this. Because it takes so long, I think it would be interesting to watch it animate the sort. So in other words, the sorting happens right here. This is so I'm going to save this, and I'm going to save a new version called Pixel Sorting Animation. So what I'm going to do now is the processing has a draw loop, right? It's actually drawing this stuff over and over again. I did all of the sorting and setup, and it was finished. But what I want to actually do is do the sorting in draw. So every single time through draw, what I want to do is sort. But instead of having a loop, draw is already looping. So I is something that can become a global variable. I'm going to call it index, set it equal to 0. I don't need this anymore. I don't need that outer loop anymore. This is going to do one pixel per frame of animation. So the selected pixel is index. J starts at index. And then, and then I swap at index, and And then what do? I say index plus plus. And I should also check if index is greater than or equal to sorted.pixels.length. I don't want I can't spell length. How do you spell length? Oh my God. If it's greater than length minus 1, I could, as long as it's less than length minus 1, I can increase it by 1. Okay? So now let's run this. You can see it's very, very slowly. You can see it kind of sorting up there, right? I'm zooming all the way in. It's happening very, very slowly, sorting by hue. Now, again, this is such a tiny resolution image that we're barely seeing it. So now I can actually, let me go with the larger image. I'm going to change this to 800 by 400. I'm going to load Sunflower 400, a higher resolution Sunflower. And I'm going to, I just need to change where I'm drawing it at 400,0. So now we can run this and I can sort of see here. There it is. You can see it sorting the pixels. Now here's the thing. I'm doing 1 pixel at a time per frame. I think it would be much nicer if I at least did a bunch. So I'm going to actually just write a little loop inside of draw to say, hey, whatever I was just doing, do that I don't know, 100 times. 100 times is not that many. There's a lot of pixels. So, so I'm going to put that so I'm only doing, now I'm doing 100 pixels at a time. And let's see what that looks like. Is it going any faster? Let's try 1,000 pixels at a time. Ooh, that's so 1,000 pixels is actually quite slow per frame. So I think I've kind of lost. One thing I want to look at is what the frame rate is. So I want this to run. I want to do the most amount as I can, the most amount of pixels I can, but still be running at 30 frames per second, which I'm clearly not. So let's do it at 100. And we can see, whoa, why is this so slow? You know what's the load? Oh, you know what might be the problem? No. Anyway, I need to, I'm gonna update this. It's very CPU heavy and it's just very slow. I think there could be some more creative ways I could think about animating this. We could let this run for a little while and see how far it gets. But for example, so this is now animating at 30 frames per second, which is quite nice. I'm doing 10 pixels at a time. And it's doing 30 frames per second, so that's 300 pixels per second. Still going to take a very long time to finish the whole thing. But there might be some other creative ways. This might actually look more interesting if I didn't draw the original image and you just saw the pixels getting filled in, the ones that have actually been swapped, or I might, if I was doing it out from the center. So I'm sure you will come up with some creative riffs off of this. Please share them with me in the comments, share them with Twitter, share them with me on Twitter @Schiffman. I hope you enjoyed this coding challenge in processing about pixel sorting. You could do this at very high resolutions. It'll take a long time to render, but then you can export it out as an image or something and make a big print. And let me know if you make something, and I'll see you again in a future video. Goodbye. Hey, guess what, everybody? I'm back. Look at this. That doesn't look right. I'm getting this interesting, strange smear, but it's not actually sorting. The reason why it's not actually sorting is I didn't notice when I move stuff around to animate it, look where the swap is happening. The swap is happening inside this J loop. I want to look through all the pixels, find the brightest or the ones with the highest hue, and at the end of that, swap it. So I just had a typo, essentially, where this closing bracket is in the wrong place. I need to close that J loop here, and now it should actually sort by hue. Okay, so now we should see something more correct. So I had that mistake, and you can see now that the sorting is actually happening correctly. Now what I'm wondering is if having the swap inside was somehow making it also run slower, and if I could actually manage to have it run faster. Nah, it's still pretty slow. It will slowly gain speed over time, because as it gets further along, oh, you can't actually see my frame rate, I just noticed. As it gets further along, as it gets further along, this is the frame rate here, as it gets further along, it has fewer pixels to check because it's getting further and further into the image, and you should see that frame rate go up and up and up and up and up. But you can see now that the sorting is actually now happening correctly, and it actually is sorting by hue. Again, by hue is not necessarily the, is that necessarily the most, There are lots of, I think this is a challenge to you, is like I just picked hue and I just picked brightness as arbitrary numeric indicators of a pixel's value as a single number. But you might think about other ways of thinking about how could you order those pixels. And so I'm gonna let this run for a while and hope you enjoy it. And also, you could pick a different image than the sunflower. You can mess around with how you're sorting it. I'm sure you'll come up with something creative, and I'll see you in a future video. I think this might really be the end. Goodbye.